So in this session, we will discuss about NAT types. Basically, we have three types of NATs. The first one is static NAT, second one is dynamic NAT, third one is PAT. PAT stands for Port Address Translation, and PAT is also known as, also called NAT Overload. NAT Overload. So first we will discuss about PAT, Port Address Translation. Okay. This PAT allows multiple private IP addresses to access internet. PAT is used for outbound communication. Remember this point. PAT is used for outbound communication. Outbound communication means inside to outside. Inside to outside. So this PAT translates not only source IP address, it also translates source port number. Very, very important. That's why it is called port address translation. Port address translation means it translates port numbers also. Which port numbers? Only source port number. Remember this point. PAT translate source IP and source port number, which means PAT rewrites layer 3 header and layer 4 header. IP address comes in the layer 3 header, port numbers comes in layer 4. It will translate source port number. Either it is TCP traffic or UDP traffic. Whatever user inside the traffic, this PAT translates port number also, source port number. The first we discussed about ports, right? So we already discussed in the beginning classes. So here see, again I will repeat one more time. Port number. Port numbers, what is the purpose of the port numbers? First of all, the port numbers are used to identify the applications, right? Total port numbers are 1,265,535. Total port numbers are 1,265,535. In this range, 1 to 1023 are well-known port numbers. Well-known port numbers means familiar port numbers. These port numbers are assigned to servers like FTP, DNS, DHCP, HTTP, HTTPS, SMTP, SNMP, right? So these are the servers, right? So up to 1023 are server port numbers. After 1023 are client port numbers. Means client will use randomly. Client will automatically use any one port number when it is initiating TCP or UDP traffic. Remember this point. Next point. And also we need to understand private IPs, right? In class A we have 10.0.0.0 to 10.2.2.2. In class B 172.16.0.0 to 172.31.2.255. Class C 192.168.0.0 to 192.168.255.255. So first I will show you here why this port number translation is required. Okay, the first to understand that one, very, very important. So this is our topology. I have only one internet connection. So for example, this is the ISP. For example, this ISP is a Airtel ISP. From Airtel, I have taken one connection, one internet connection. So this is the ISP cable. I have connected this ISP cable to my edge router. This is my edge router. Edge router means which is connected to ISP. So I connected internet cable to edge router on port number F0/1, right? So for F0/1 interface, I configure public IP 200.0.12.1. This is the public IP address. Whenever you connect any device to internet, so we usually use the public IP, right? Okay. So generally in the production we have a firewalls, but this is the CCNA course, right? So here we discuss about the routers only, not a firewalls. But in the production we have firewalls only. Okay, firewalls are connected to internet only in the real production. Okay, so right here this is the CCNA course. That's why we discuss in router only. Okay, see this is my edge router. So this router is connected to ISP, Airtel ISP. Okay, through F0x1 interface. So here F0x1 interface, we have a public IP 200.0.12.1. ISP side 200.0.12.2 IP. What are my internal networks? My internal networks are 192.1.1.0 and 192.1.2.0 network. These two are private networks, Class C private networks. And see here, outside, there are some servers. These servers. There are 3 servers. One server is a Facebook, one server is a YouTube, one server is google.com. Facebook server IP address is 172.32.0.2. This is the public IP. YouTube server IP is 172.32.0.3. Google server IP address is 172.32.0.4. These are the public IPs, public servers. Now, my users, my company employees, my company users, 192.1.1.0 network users and 192.1.2.0 network users should be able to access these servers, public servers, right? Should be able to access these servers. But actually here, users are using private IP. With the private IP, they can communicate? No, it is not possible. If this user wants to access internet, so these private IPs should be NAT to public IP. So here we have a public IP 200.0.12.1. So I will translate these all private IPs to this public IP. All private IPs. How many private IPs are there? See, this is a network 192.1.1.0. So here we have a 254 IPs. Here we have a 254 IPs. 254 means here more than 500, right? These 500 users should be able to access internet. So for these 500 users, no need to purchase 500 public IPs. We can purchase only one public IP. We can use one public IP. We can save that public IP to these 500 users. That is the advantage of the PAT. PAT advantage is what? Many private IPs to one public IP. PAT translates many private IPs to one public IP, right? But how it will translate many private IPs to single public IP? Now we will discuss, right? So first to understand here, PAT translate port number and source IP. Remember this point, okay? This is very, very important. PAT translates source IP and source port number. Okay. So now here I will explain here, okay? Why port number translation is required, okay? So now this is Facebook server 172.32.0.2. Okay. For example, this user wants to access this server. First user, this user 192.168.1.2, this user 192.1.3, this user 1.4. The first we need to understand why, if port number is not translating, what happened, okay? First understand that one, okay? If port number is not translating, what happened, okay? Right. So now here 192.1.1.2 user is visiting Facebook server. Okay. So now here what happened? So first to this machine, prepare packet, right? So packet means like this. First to data, HTTP data, then TCP header. In TCP header, source port number, what? Source port number means, I told you, right? Up to 1023 are server port numbers. After 1023 are client port number, okay? Client will randomly select any one port number, okay? For example, this PC selected port number 1024. Destination port number 80. Next, what the source IP? Source IP is 192.168.1.2. Destination IP, server IP 172.32.0.2. This is original packet. This is before NAT, right? So first PC send this packet to router. Then router will translate this private IP to this IP, public IP 200.0.12.1. Okay. So here, before sending this packet, router will perform NAT, right? See here. So here what happened? First to data. In the TCP header, source port number 1024, destination port number 80, and the source IP 192. This IP change, right? 200.0.12.1. This IP interface IP, outside interface IP, and destination IP remains same 172.32.0.2. This is the packet. This is after NAT. Okay, and forward to ISP router. ISP router will forward to here. Okay. In case, if for example, if the second user at the same time, this user is also going to visit Facebook server at the same time. So this system will also prepare the packet, right? So this time the packet is like this. This packet is same packet, data first, and then source port number, same port number 1023, because it's a random number, right? And destination port number 80, and the source IP 192.168.1.3, and destination IP 172.32.0.0.3. First, this packet also sent to router. Again, this router will translate here, right? See here. Here what happened? After translation, what happened? First to data. Source port number, that's destination port number 80. Source port number 1024. Source IP. Source IP is public IP, right? Source IP what? 200.0.12.1. Destination IP 172.32.0.2. Same. See now what happened? This packet and this packet. Is there any difference here? No difference. So router will translate these IPs and it will forward to server. Then what happened? This server has received two requests. In these two requests, same source IP, same destination IP, same source port number, same destination port number. So how this server can understand? How this server make it differentiate between these two requests? It is not possible, right? The server thinks like it is a same request coming two times. It is a duplicate request like that, right? This is the problem. So server responds only one time, right? So that's why here port to translation is required. In case here why this problem came here? Because 192.1.1.2 system and 192.1.1.3 system selected same source port number. That's why this problem came here. But if in case if these two systems are using the different port numbers, source port numbers, for example, 192.1.1.2 system, if you use port number 1024 and 192.1.1.3 system, if you use 1025, there is no problem here. No need to translation here. Actually, port translation, right? If all client users, all users are using the same different port source port number, there is no problem here. But these are the client port numbers. The client port numbers randomly selected here. Same port number might be used by multiple clients. This is called conflict, right? So whenever multiple users are going to same destination, okay, if they are using the same source port number, this is the problem. Because all private IPs are NAT to single public IP 200.0.12.1. Understand, right? Why port translation is required. So that's why what happened here, even clients are using the same port number, router will translate this port number. So router here, see, the first request 1024, right, source port number, it will remain same, it will put same. And the second system is what? Second user is also same port number, right? So here router translate 1025 or 1026, 1027, 1027 like that. If there is a conflict in the port numbers, then only router will change. Then only router will translate. Remember this point. If these two users are using different port number, then router will not translate. Okay, that is no need also. But when more than one user using the same port number, the router should translate port number also. This is the pact. So right, but here in case here both users are going to same server, right? That's why problem came. But in case if 192.1.2 users is going to Facebook server and 192.1.3 user is going to YouTube server, so that time no problem. That time these two users can use the same source port number. Why? Because destination IP is different, right? So the problem coming is whenever multiple users are going to visit same public server with the same source port number, then only we face this problem. So in this case, the router should perform the port translation also. Understand, right? So in next section, I will show you how to configure this port address translation, and I will show you whether port address translation is happening or not. Okay.